All right, I'm going to do a series of free body diagram examples here, and this is going to assume that you've already had some notes on normal force and applied force and how to calculate weights using mass and gravity. So we're just going to jump right in. So our first problem here says draw a free body diagram for a 30 kilogram box sitting on a flat surface. So I'm going to go ahead and draw my flat surface and get my box in contact there. Remember, we're just going to draw these as squares. And then I'm going to go ahead and put my 30 kilograms in the box. Next time I'll draw that a little bit bigger. And then what forces do we have acting here? So we have a force of weight down. And because that box is sitting on a flat surface motionless, we're going to have a force vector up, the normal force. And so let's go ahead and calculate what those forces would be. So the force of weight is going to be mass times gravity. And for simplicity here, I'm just going to use 10 meters per second squared for gravity. So we're going to do 30 kilograms times 10 meters per second squared. That's going to give me 300 newtons. So my force of weight is 300 newtons. And in order for that box to be stationary, we would need a net force of 0. So I have to have another force upwards that's 300 newtons. Pretty simple. All right, draw a free body diagram for a baseball thrown through the air. Now, if you think back to the projectiles unit you've had, you'll know that the definition of a projectile is anything that's really under only the force of gravity. So if this is my baseball, I'm going to have just the force of weight. Now, they don't tell me the mass of the ball, so I can't do anything specific here. I would just have the force of weight pulling down on the baseball. And that's it. That's as simple as it gets. You could, I suppose, if you wanted to be complicated, include air resistance, but that's going to change depending upon which way the ball is moving. That just gets really complicated, so we'll skip that. All right, draw a free body diagram and solve. It says a rightward force of 7 newtons is applied to a 2.5 kilogram book in order to move it steadily. Now there are some key words you should look for. Move it steadily implies there's no change in its velocity. So it's not accelerating, which means there should be 0 net forces on this thing. All right. Consider frictional forces, and they want to know what the coefficient of friction would be. All right, so let's go ahead and get our surface. And we'll put our box on here, or our book. And I promised you I would go a little bigger here, so let's draw a bigger book here. 2.5 kilograms. Now I know that's a little sloppy in there, but you can see that. Okay, and I've got a 2.5 kilogram book. So my force of weight on this is going to be mass times gravity. 2.5 kilograms times 10 meters per second squared is going to give me 25 newtons downwards on that book. So my force of weight is 25 newtons. And because this is not on a slope and it's not accelerating up or down, I know that my normal force is also 25 newtons. Okay? So then I know that I have a rightward force of 7 newtons. So my force that's applied is 7 newtons. And if it's moving steadily, then I need 0 newtons of net force, which means that my force of friction is 7 newtons. Now, that gets me partway through my problem, but the question asks me, what is the coefficient of friction? Not just what's the force of friction. So let's go ahead and remember that our force of friction is equal to mu times the normal force, mu being my coefficient of friction. So if we do a little rearranging, the coefficient of friction is equal to the force of friction divided by the normal force. Now I'm going to move over here where I have a little bit more space. So the coefficient of friction is the force of friction divided by the normal force. My force of friction here is 7 newtons. And my normal force is 25 newtons. Okay. Get that where there's no glare on it here. And we'll do 7 divided by 25. And we get 0.28. And the newtons cancel, and there are no units. Coefficients of friction don't have units with them. So that would be the answer to the first 3 questions there. We'll go ahead and stop here, and then we'll deal with a couple more friction problems in a second.